Hey everybody, this is Brad Dyke. How you doing? This is me reaching out to you to say hi. Now, the past couple of videos I've done have been technical based. And the other ones I've done have been more of design implementation, operational kind of stuff. And I've spent a whole hell of a lot of time, pardon my French, re-educating myself to the newer variation standings of GitHub and using a new series of steps at which we're developing in our environment so that I'm keeping current with those technologies. But I thought to myself, you know what? You see, if I take a look at that back environment over there, I noticed something that it's time to address. Let me show you what I'm talking about. So as you can see here, I have a 48-port switch, Dell 6200 series. And I've got up here a Juniper platform. And of course up here I have the Haagen-Dazs, which is the Microtech cloud router switch. Now, out of these, this is my oldest one. A friend of mine gave me this. We've used it for churches and stuff, and I brought it back into use in my lab. I went through recycled that equipment for newer stuff. But it's just strictly a 1 gig switch. Great switch, excellent switch, fully redundant. And the Juniper up here is in the same same setup, but the Juniper's been disappointing because it's just not doing what I needed to do. So I've actually had to turn it off. And yeah, if you listen carefully, my lab is powered down. And then I've got the Microtech 8-port bridge, and then in the back here, I have a Microtech 4-port 10 gig switch. So what am I trying to do here is, what I should say is what I'm trying to say is I want to change this up. And it's time to go probably 100% 10 gigabit. And I don't mean just here. So what I've done is I've gotten some equipment. Let me show you what I've got here real quick. Put this down here and point down. Okay, so as you can see here, I've got myself what's called an 8-inch feed 19U footprint with a single 1U model configuration designed for housing, but it's very thin and has a protective coating on it designed to keep heat away from it. Because remember, every piece of metal you've got in your environment is a source of heat. Along with that, it comes with your typical clamp bolts, and of course it has an L-frame adapter set, which you have to put it together the way you want it, because some people might want it backwards, some people might want it frontwards. It just depends on what you're trying to do. So they're usually also referred to as going telco version versus standard IT operations version. And of course we've got the typical rack mount kit screw and anchor bolt, which is the one you want to have for strength, opposed to the C-clamp version, which is not so strong. Then, of course, we have this little guy. Now, I've thought about this in different ways, in different housings, and different possibilities, but I decided that I wasn't going to do that. I was going to try to stay somewhat small as I made this transition. Now, in the house infrastructure, I'll use a full-size switch, but this is basically a GoodTop vendor 8-port GBIC SFP Plus platform. And as you can see here, it has caps on them, and if I pull those caps off, there's a GBIC slot there for it. I'll put that back on, and it's going to go here on this platform in a secure format, so I have a little bit of play with it. And then comes the power supply. That's about it. It's basically a $99. I bought it for $99. It's 10 gigabit, but I didn't get an isolated infrastructure switch, which basically means that you're going to have either true GBICs, and you also have a Cat5 RJ45 heads, and so on. This is a hybrid set where I could do anything I want to do. And what do I mean by that? Well, the first option, obviously, I could do is I could just simply do a GBIC class connection that is, give me a second, I'll pull it out, an RJ45 version. Now, what that basically means is that if I open this up, you will see it is an RJ45. It's got gold head on it. It has a release lock sleeve on it. And you should at least have one of these specifically for port 1 or port 8. And what this does is it allows you to be able to hang on a second. It allows you to be able to Cat 5 up to this at any speed. 10, 100, 1000, 10 gig. It doesn't matter. It's got the release set on it, which is right there. As you can see, it's a good first port to have. But I also want to have a couple more just for the ability of working with my outbound. So I've got 2 more here. Now, another very important variation, because this is open-ended, which means I can have a different design structure to it. I also got these. And these are copper GBIC SFP direct connects. And if you take this head off here, and you'll be able to put it right in. Oops, sorry, backwards. And it goes right in place, like it should. And that's copper and totally enclosed. So it's the optimal 10 gigabit cable to use, specifically when you're going to bridge multi-switches. So what do I mean by multi-switching? Well, obviously I've got a couple of these cables, and I've already have 10 gigabit cables over there because I already have 10 gigabit infrastructure. So with that being the case, what am I doing? Well, I'm eliminating my 1 gig switches is what I'm doing. But at the same point in time, to do that right, I also have to make sure that I have the ability of doing copper. Now, my baseline thin client style Proxmox clusters will continue to run on a 1 gig switch because it is specifically designed for that. But this guy is going to do all of my core servers. Now, I already have ports out there. So what I'm doing here is I'm augmenting my total of 12 ports to 18 ports. So by adding these guys to the equation, bringing this guy as in a loop over, I will go over here, way over there to that 10 gig Microtech switch, which you see right here, and I will pair this connection to here, but I'm going to put it over on this side along with the 4-port switch and transition the trunk of that switch over to there, freeing a port up here. So I'll just have 1 port in use here and over. And I'm also going to splice my fiber pairing, which is right here, to my master switch, so that this guy will have that direct connection as well. Now, what's the weak link here? Well, the truth of the matter, the weak link here is obviously my core building switch, which is a Netgear, I think it's a 5842, and it's quite a capable switch. It's done me great. It's got 2 GBICs, actually 4 GBICs, that I could hook up for fiber optic connectivity and or additional bandwidth at the core rack enclosure down in my basement. That's my 3rd rack, by the way. But what I think I want to do is I'm looking at, and I just purchased it, is a Dell series managed switch, which is a 4232 series 10 gig switch, which has GBIC bridges for fiber optic connectivity that will come over here to my 10 gig switches in the lab and will route the 10 gigabit bandwidth between the core switch and everything else. Now, why did I do that? Well, number one, it's got 24 ports on it that are copper. There are copper 10 gig switch connections. And so that means the house can continue to stay on the current Cat 5 configurations I have out there, which I did use Cat 6. So it's definitely going to be a really good bandwidth. It's just not going to be maximized bandwidth with 10 gig. More importantly, my workstation in my office area can now go 10 gig. And I still use 1 gig switches all throughout the house whenever I need something for extra ports or something like that. And I put them on, I take them off, put them on, take them off. But the key thing here is to make sure that when I'm doing this, that the connection that my system specifically is connected to is a Cat 6 connection all the way to the switch, which will give me a very good bandwidth, much faster bandwidth, because I move a lot of stuff on that chassis, and it's quite substantial overall. Now, with that being said, the other key thing is I have a lot of 10 gigabit here already. I have cards, I have cablings, I have fiber, I have copper, so I don't have to buy an extra lot of GBICs. And GBICs can run you about, well, for instance, I bought this 10-footer for $14, right? And you could get the $25 RJ45s if you have like copper 10 NICs. They're not expensive, but they're not absurdly cheap if you buy them based on specific needs. Now, another thing to which I did is I got these guys. Now, these are managers, right? And what they basically do is you have your cabling going through here, and you've got your top piece, this guy right here, which will close it, and the end result is that you have an obscured view of your cabling, keeping everything kind of clean and neat. I do too much testing and too much configuration to try to keep everything well organized and pretty. It's nice, but it's not practical. Those lab people out there that love their homes, their home labs and all of that, that's pride. And that's cool. There's nothing wrong with that. But when it comes to the practicality and you look at it and say, oh my gosh, what am I going to do to keep this looking good while I need to do this next whatever testing model we could do? Well, the answer to that is very simple. Have devices like this that can take that cabling and move it off quietly to a good place. Now, with that being said, also other very important thing is, unlike fiber optic cabling, using the copper 10 gig GBIC bridge cables like this one is excellent because it gives you a lot of flexibility that a lot of times you just don't get. So with that being said, the next thing I've done is I've ordered a brand new, well, not brand new, excuse me. It was ordered from eBay. I bought it from a company that refurbished it. Is the 4232 switch. It's a great switch. It has a lot of flexibility to it. And if I use that as the top architecture, it would be the best architect switch I have. What do I mean by that? Well, okay, so you got to understand, when you're looking at switches, let's talk 8 gig, right? That's a good example. When you're looking at an 8 gig switch, the design of the switch is propagated by the number of functional ports it has. So in here, it's usually supposed to be 1 plus your total port number, which would be your maximum bus on the front end. So little guys like these do great in handling just core 10 gigabit traffic. Can't do really super advanced stuff, but it also doesn't have what's called a distributed bus on the back. It has a single bus, but in this case, this is a 90 gigabit bus. So it has slightly enough bandwidth over and above to act as the management bandwidth over all 8 ports, because there is a lot of communication that happens inside the switch that you're not aware of that is required for the TCP/IP protocol communication. We call this the overhead. In other words, so if you have a 10 gigabit connection, you actually get like 8.2. If you had a 1 gigabit connection, you actually have like 820, 850, and so on and so on. And that overhead is just a requirement. You can't get away from it. So with that being said, I'm going to test this GoodTop 8 gig switch in my design implementation, and I'll do a video on that. And I'll also the manual. I'll also review the manual to make sure I understand the proper logins and all of that and get this set up so I can start prepping both the switches for the new bandwidth that I'm wanting to do. So with that being done, I'll have a the 4232, which has closer to about 150 gigabit bandwidth, and it's split busing, which means it has the ability to offload to support things like full duplexing. I'm not going to do that, of course, but the key thing is that bandwidth on my core switch, which will be sitting in the basement of the house, will be absolutely 100% bandwidth per port. As for this particular port, with the bridge connection being a provider to a 1 gigabit interface link, I might just put a GBIC 1 gig in for the uplink to the out point. But I've also decided maybe I don't want to do that. I'm still working on that design model. I'm going to continue to draw it out on my paper to see how I want it to look. And then that will become my final version. Once I've got that done, I'll secure the cabling feeds and the assembly sets, and make sure that I've got them properly hidden with my nice my wire plenum containment systems here. And this will be a dramatical, probably a 60% increase across the board, because now my workstation all the way to my lab and back to the workstation will be 10 gigabit. I use fiber optic outbound and inbound at 1 gigabit each, and that provides the ability for me to be able to do half duplexing because it is a single connection. I don't have the resources where I could double up and create a full duplex connection, but the key thing here is that when you're doing this kind of stuff, and you have to have it so that you can test it, but you don't necessarily need to go out and buy a 1U half deep switch with redundant power supplies and a lot of what I call overhead, because Nortel, Juniper, all of them, Cisco especially, be careful what you buy in Cisco switches because they will nail you with licensing fees. I never touch Cisco. I can support it, but I don't want to. All in all, though, in general, this setup is pretty good. Now, one last thing I'll cover about this is that when I do this, when I take this and I'm going to make it into a stationary platform using my 1U fitter, I'm going to be using Velcro to secure this guy significantly well, so that I can slightly raise it higher over the bevel point, but also make sure that it stays stationary permanently. That's what happens when you take desktop style switches, and you've got to learn how to immobilize them and lock them down so they turn into something like this. Nice thing is, though, you get shelving on the left and shelving on the right for either pass-throughs, wire guides, and so on, or you can just have it for holding GBICs and covers and plaques and whatever you want. It's about practicality. It's not about looking pretty. Well, this is Brad Dyke. I hope you enjoyed this little blurb video I did on this switch. I will tell you as I go forward with the hybrid mix, what are the results with this switch, and is it going to meet what I would need, and can it properly emulate 10 gigabit? That's what I truly need. But for now, I'm going to let you guys go, and God bless. Take care.